Okay. Hello everyone. Igwe, Matis. Yeah. Exam week is about starting, and I'm not really sure if I'll have time during the exam week to create these videos. So I'm creating using this time this Sunday to create the test review questions for. I've already created a test review question for Maths 1 to 2, test 1. So I'll do test review question for Maths 1 to 3, test 1 now, and I'm going to create a test review for test 2 for both of them. I'll try my best to create both of them today, the three of them today, and just post all of them. I've already done one of them, one out of four. So remaining three, I'm going to try my best to do the remaining three today and post. But if I cannot do the remaining three today, then I have to do it maybe 2 days before the exam, because I cannot jeopardize my other subjects for my maths. With no further ado, let's begin. We have 15 questions for maths, MTH 1 to 3, test 1. The first question asks us, which of the following statements truly represents scalar quantities? Now, what are scalar quantities? Scalar quantities are things that only have magnitude. They are quantities that only need magnitude to represent them fully. You don't need their direction. Scalar quantities include things like speed. For speed, I can tell you, oh, I am moving 2 meters per second, and that is my speed. But for my velocity, I need to tell you that I'm moving 2 meters per second towards the lecture theatre, or towards the classroom block, or to your left hand side, or to your right. I need to tell you the direction. Okay, another thing that needs direction is force. If I tell you that I am pushing the block with 2 newtons of force, you cannot really tell by just that 2 newton where the block is moving. You need to tell me also which direction that block is moving towards. Okay, which of the following truly represents scalar quantities? Option A, 10 newton and density. Density is a scalar quantity, but newton is not a scalar quantity. Okay, so we have 10 newton. Newton is the unit for force. So, and we know that force is a vector. So since one of them is a vector, then that is not going to be the correct answer. Both of them must be scalars. Option B, it is force and mass. Force is a vector because it needs direction for you to define it completely. So option B is wrong. Option C has acceleration. Acceleration is the derivative of velocity. Velocity is a vector, it needs direction. And in fact, acceleration itself is the force per mass. So basically, it's also still going to be a vector. So since acceleration is in option C is wrong. Option D has velocity and acceleration. Both of them are vectors. So option D is completely wrong. Option E is going to be the only correct answer because none of the above are vectors. None of the above, are completely scalar quantities. The other options have vectors in them. So the correct answer is going to be none of the above. Let's go to question 2 now. Question 2 says, find the direction ratios and the direction cosines of the vector A equal to I minus J minus K. Now, what are direction ratios? Direction ratios are basically, let us say, vectors that move in that same direction as the vector that you are given. Let us say you are given the vector A is equal to maybe 2I plus 2J plus 2K. Then I plus J plus K is also in that same direction but with a different magnitude. Now let me just show a graphical representation of that. Okay, we have our Cartesian plane like this. Okay, now we have this vector moving in this direction, whatever this direction is. But we have this vector moving in this direction, and we have another vector moving in that same direction but it is shorter. We have another one that is even shorter than the first one. Now they are all moving in the same direction, but they are having different magnitudes. This vector A is basically not equal to this vector B because their magnitudes are different. And vector B is also not equal to vector C because their magnitudes are different, but their directions are the same. So their directional cosines are the same. No, they're not really the same because there are infinitely many directional cosines for a particular vector. It's basically just that all those vectors must be in the same direction, and you can have infinite many vectors in one direction because it can be 1 centimeter long, it can be 2 centimeter, it can be 3 centimeter, it can even be 1.1, you understand? So it can be infinite many directional constants, but there's only infinitely many direction ratios, but there's only one direction cosine. And direction cosine, the reason why there's only one is because there's only one out of all these vectors that are moving in the same direction, there's only one of them that will have a magnitude of 1. You cannot have a vector that have magnitude of 1, there is a direction cosine of this vector that is also moving in this other direction. No, they must all that direction cosine must move in that same direction, and it has only one magnitude. That is magnitude of equal to 1. The magnitude is equal to 1. So there's only one of its kind. But for direction ratios, there are multiple of its kind. It's just in the same direction, but the magnitude is not specified. Good and fine. Now that I've explained that, let's try to solve this question. The question gives us that the vector A is equal to I minus j minus k. The first direction ratio that you can get from a vector, or let's say it's vector A equal to AI plus AJ plus AK. The first direction cosine you can get is A, comma A, comma A. Let's give an example. Let's say you have vector X is equal to 2I plus 3J plus K. The first directional ratio is 2, 3, 1. This is the first. Then you can now manipulate it. You can divide it by any number you want or multiply by any number. Another direction ratio can be 4, 6, 2. You can have 1, 1.5, 0.5. I getting all these three vectors are in the same direction as the original vector that you are given. So the first direction ratio you can get from this vector that we are given, I minus j minus k, is going to be 1, minus 1, minus 1, because this is the coefficient of I, coefficient of j, and the coefficient of k. You can get multiple other direction ratios from this. You can get 2, minus 2, minus 2. Is also going to be the same direction. You can get multiple, infinitely many direction ratios from this. But one thing you cannot do is to multiply by 0. You cannot multiply by 0, because if you multiply by 0, you're basically just doing 0, 0, 0, which is a null vector. It does not point in any direction. It does not have direction, but it has a magnitude of 0. So this is not allowed. Multiplying by 0. You can also divide by 0, because divide by 0 will all turn all this to tends towards infinity, which does not basically make sense. So don't divide by 0. But you can multiply by any other number, and you can divide by any other number. Now, if you are giving this question in theory, I really don't know how they would want you to set your answers, but they will restrict it for you. Either they will tell you the direction ratio that has a magnitude of 1, then what you're finding is the direction cosine. Or they will tell you that the direction ratio has a magnitude of 2. Then after you find your direction cosine, you multiply by 2. But if it's OBJ like the one that we're giving now, you first of all write the first standard direction cosine, first standard direction ratio. Then also they give you an option with 0 points. Let's say they give you an option that the thing starts with 0.5. You then check it. The second one must be minus 0.5, and the third one must be minus 0.5. If you get anything other than maybe you have plus 0.5, then you know that option is wrong. Let's say the next option has 2, minus 2, plus 2. You know this is also wrong, because it's not in the same ratio as the one we are giving. Good. So these are our direction ratio. 1, minus 1, minus 1. Now let's find our direction cosine. Your direction cosine must have a magnitude of 1. So basically, if we have this and this has a magnitude of x, and you want to make this have a magnitude of 1, what do? You divide by x. If you divide by x, x will cancel out and you have a magnitude of 1. So let's find our magnitude. The magnitude of a vector A is equal to the square root of ax squared plus ay squared plus az squared. In this case, our ax is equal to 1, our ay is equal to minus 1, and our az is equal to minus k. So we have this is equal to the square root of 1 squared plus minus 1 squared plus minus 1 squared. This is equal to the square root of 1 plus 1 plus 1, which is equal to the square root of 3. So this has a magnitude of square root of root 3. So if we want to make this a unit vector, which defines our direction cosine, then we are going to divide our direction ratio, or this standard direction ratio, divided by that magnitude. So if we divide this by root 3, what do we get? We get another direction ratio, which is 1 divided by root 3, minus 1 divided by root 3, minus 1 divided by root 3. Now this particular direction ratio, as I explained, is the direction cosine because it has a magnitude of 1. I believe this answers the question. Let's check our option. Option 1 says 1 comma 1 comma 1. That is wrong. It's not the correct direction ratio. Option 2 has 1 comma minus 1 comma minus 1. That is the correct direction ratio. Now let's check the direction cosine. You have 1 over root 3 comma minus 1 over root 3 comma minus 1 over 3. That's correct. So our correct answer is option B. Now, in case you are not sure if your solution is correct, let us say you want to confirm your answer. How do you confirm your answer? Well, to confirm your answer is simple. Just carry this direction ratio, square each of them. 1 over root 3 squared plus minus 1 over root 3 squared plus minus 1 over root 3 squared. If you square this, you're going to have 1 over 3. Square this, you're going to have 1 over 3. Square this, you're going to have 1 over 3. So the sum of that is going to give you 1. So that basically proves that your solution was correct. Let's move on to the next question. Okay. The next question is question 3, which asks us to find the magnitude of x. Now, this question was given as a bonus, but the reason why I'm going to just explain for you the reason why it was given as a bonus. But okay, question 3 says we should find the magnitude of x if for a unit vector a. Okay, we should find the magnitude. This is what we're looking for, the magnitude of vector a. If we are given a unit vector a, we should find the magnitude of vector a. If we are given a unit vector, instead of this, let's do it as this. Let's write like this: a unit vector, given a unit vector a. Okay, we were also told that the vector x minus the vector a dot or dot product the vector x plus the vector a is equal to 15. Now, how do we solve this? The first thing we need to do is to try to evaluate the dot product of x minus a and x plus a. Now, to do that, I'll just create an arbitrary vector x is equal to x, let's say xx. But instead of x, let me use a for simplicity. Let's say the vector a is equal to axi plus ayj plus a. Let's just use 2 for just ease. Okay, and we have another vector b is equal to bxi plus byj. So the vector a plus the vector b is going to equal to ax plus bxi plus ay plus byj. The vector a minus b is going to equal to ax minus bxi plus ay minus byj. Now, if I find the dot product between a plus b and a minus b, remember how we do dot product. The coefficient of all the i's will multiply together. The coefficient of all the j's will multiply together. The coefficient of all the k's will multiply together, and we add them up. So let's multiply the i's of a plus b and a minus b. If we're multiplying the i's, we're going to have ax plus bx times ax minus bx. Ax plus bx times ax minus bx is basically just ax squared minus bx squared. Now, why is it ax? Or I don't know how to write this down that it to be, because the board I'm using now is small. So I'm just going to clean this top part here. Okay, so this here is going to equal to, you have ax times ax plus bx times ax minus bx is going to give you ax squared minus bx squared. You can remember this from difference of two squares. The difference of two squares is equal to a plus b times a minus b. So you have ax plus bx times ax minus bx going to equal to ax squared minus bx squared plus multiply the coefficient of j's. The coefficient of j is ay plus by. The coefficient of j is ay minus by. Ay plus by times ay minus by is going to equal to ay squared minus by squared. Now if you look at it, you have ax squared minus bx squared plus ay squared minus by squared. Now if we do some rearrangement, we are going to get ax squared plus ay squared minus bracket open bx squared plus by squared. Ax squared plus ay squared sounds familiar, and this is the magnitude of vector A all squared. Because remember, the magnitude of vector A is equal to the square root of ax squared plus ay squared. So if you square both sides, you're going to have the magnitude of vector A all squared is going to equal to ax squared plus ay squared. The same thing happens for bx squared plus by squared. This should be minus the magnitude of vector B all squared. All squared. So now we are given x minus a times x plus a. This would basically be the magnitude of vector x all squared minus the magnitude of vector a all squared. Remember, a and b we are just invited, we are just introduced. I introduce them as arbitrary vectors, like just any two random vectors. But in this question, we are given the vectors that we are supposed to use, vector x and vector a. So I'm substituting it back here. X minus a times x plus b, x plus a is going to give you the magnitude of vector x all squared minus magnitude of vector a all squared. So now I can clean all this. From the question, we are told that this dot product is equal to 15. So we know that this difference of magnitude squared is going to equal to 15. Now what else can we do to this? We are told to find this one, but we are we given the magnitude of vector A? Well, we weren't giving it directly, but we are giving it indirectly. We are told that the magnitude of that vector A is a unit vector. Let me read the question again so you can see it directly. Find the magnitude of vector x if for a unit vector A, as we are told that vector A is a unit vector. So this magnitude of vector A here, instead of magnitude of vector A, we are just going to replace it with 1. So here will just be 1. So now we have the magnitude of vector x squared minus 1 is equal to 15. You do some algebra, you have the magnitude of vector x all squared is equal to 15 plus 1, which is equal to 16. If you take the square root of both sides, you are going to have the magnitude of vector x is going to equal to the square root of 16, which is equal to plus minus 4. But we are going to take only just the positive 4. So we are going to get the magnitude of vector A. Okay, no. This question is going to confuse a lot of people because just now I'm seeing it now that we were actually told that the magnitude of vector A is equal to 3. So if we are solving for the magnitude of vector A as 1, that is this is in the question they said giving a unit vector. That unit vector means the magnitude is 1. If we are solving with the magnitude of 1, we are going to have the magnitude of vector x is going to be 4. And 4 is not in the option. But I'm also saying now that they told us now that giving magnitude of vector A is equal to 3. Now that can cause confusion. So that's why they gave this question as a bonus. In the marking guide, this question was actually given as a bonus. There was no option for this question because it caused confusion. You have they first of all say that giving a unit vector A, that is the first of all say that the vector A is a unit vector. Then at the end, they now say that the magnitude of vector A is equal to 3. It's contradicting themselves. Magnitude of 1 and magnitude of 3 are not the same. That's why they give this as a bonus. But now just solve it as if. So in case you see that, why am I stammering? In case you see this question in your exams, at least you know how to solve this type of question. But watch out, in case they don't tell you the magnitude and you see giving a unit vector A, you're going to use the magnitude as 1. So now let's just solve it again if the magnitude was 3. Let's say the question came out as giving a vector A, they not specify a unit vector A. You just say giving a vector A, then at the end they now added that magnitude of vector A is equal to 3. How do you now solve this? Now from here, remember we had the magnitude of vector x all squared minus magnitude of vector A all squared is equal to 15. The magnitude of vector A was given as 3, so this here will be 3. 3 squared is 9, and 9 plus 15 is 24. Yes. So the square root of 24 would now equal to the square root of 4 times 6, which is equal to 2 root 6. and 2 root 6 is option A. But remember, this question is actually a bonus because there are two answers. They told us unit vector, which is magnitude of 1, and they also gave us the magnitude as 3. So it causes contradiction. So this question was actually a bonus. Let's just say bonus. So actually a bonus. But remember, I just showed you how to solve the question now. So in case you see this question in exams or in future, you know how to tackle it. Whenever you see the magnitude of x minus magnitude of a dot the magnitude of x plus the magnitude of a is equal to 15, then you already know how to expand this to give you the magnitude of vector x minus the magnitude of vector x squared minus the magnitude of vector a squared. Let's go on to question 4. Question 4 is actually also another bonus. Question 4 says, find A and B if 2i plus 6j plus 27k cross I plus alpha j plus beta k is equal to A. Now, the reason why this question is not solvable is because A that is there is not a specific vector. They didn't tell us what that vector A represents. If they told us, just like I can remember this type of question that they will ask, if you are given the root of an equation, you should find the quadratic equation that that equals to. Or this type of question that you'll be given something like x squared minus bx plus 1 is equal to 0. You should find the value of b that will make this expression a quadratic. Sorry, this thing have the same root. For them to have the same root, remember that b squared minus 4ac must equal to 0. So you can solve this. But let us say they now give you another question like p plus q x squared minus p minus q x plus 6 is equal to 0. Or let us say it's equal to a quadratic. Find the value of p and q. You can see in this case it's not solvable because p plus q, you are not giving what it represents in that quadratic. But let's say they gave us that quadratic as 4x squared minus 2x plus 6. Then if you compare the coefficients, you have p plus q is equal to 4 and p minus q is equal to 2. Then you now solve this using simultaneous equation. You can get the value of p and q. But in this case, let us say I not give you what the quadratic was. I just said p plus q x squared minus p minus q x plus 6 is equal to a quadratic. You cannot be able to solve this type of question. But let us say I say it's equal to f of x. You can't solve this type of question. There's no way you can tell me what the value of p and q is. That is the reason why they gave this question as a bonus, because we were given that 2i plus 6j plus 7k cross I plus alpha j plus beta k is equal to a vector A. They didn't tell us what that vector A is, so this question is not solvable. But now, just for the sake of exam, I believe they will set this type of question again and maybe correct the question and tell us the actual question. Like maybe they made a typo. So I'm not going to assume an arbitrary vector. I'm going to assume a vector that we're going to use. But for simplicity, I'm going to first of all expand, then assume a vector that will make it simple for us to solve for. Okay. So we have 2i plus 6j plus 27k cross I plus alpha j plus beta k is equal to vector A. Okay. Now, how do we handle cross product? Cross product is simply just like, it's basically almost the same as scalar products. It's just that instead of I times I to equal to 1, I times I in this case is going to equal to 0. I times j is going to equal to k. I times j is going to equal to k. J times k is going to equal to I. And k times I is going to equal to j. The other way around, you have minus. j times I is going to equal to minus k, I times k is going to equal to minus j, and k times j is going to equal to minus I. So let's expand this. You have 2I times I, that will be 0 because I times I is 0. You have 2I times alpha j, I times j is k. So 2I times alpha j will be 2 alpha k. 2I times beta k, I times k is minus j. This will be minus 2 beta j. 6j times j times I is minus k. So 6j times I will be minus 6k. 6j times alpha j will be 0 because j times j is 0. J cross j is 0. 6j cross beta k, j cross k is I. So 6j cross beta k will be plus 6 beta I. 27k cross I, k cross I is j. So 27k cross I will be plus 27 j plus 27j. 27k cross alpha j, k cross j is minus I. So this will be negative 27 alpha I. K cross k is 0, so 27k cross beta k will be 0. So now we have, let's rearrange it in terms of ij and k. We have 6 beta minus 27 alpha I. For j, we have plus 27 j minus 2 beta j. Sorry, plus 27 minus 2 beta j. Plus, for k, we have 2 alpha minus 6k. So now we have I, j, and k. If we are given a complete question, we will be told what vector A is. Let's assume vector A is equal to I plus j plus k. Now, this may not be solvable. The reason why this may not be solvable is because this will have to be a simultaneous equation. That means you must satisfy the three of them. If I'm best setting the question, I'll first of all solve for what the left hand side would be. Then pick a vector that would have a solution. Okay, let's assume that our vector is I plus j plus k. The next thing that we're to do now in this solution is to, let me clean this box now, is to compare your coefficients. You have, for I, we have 6 beta minus 27 alpha. So you have 6 beta minus 27 alpha is equal to 1. And you have 27 minus 2 beta is going to equal to 1 because that's coefficient of j. And we have 2 alpha minus 6 is going to equal to 1 because that is the coefficient of k. Good. So let me clean this up more. So let's pick equation 2 now. We have 27 minus 2b. This will be 27 minus 2 beta is equal to 1. We have 26 is equal to 2 beta, and we have beta is equal to 13. Let's pick equation 3 now. We have 2 alpha minus 6 is equal to 1. So you have 2 alpha is equal to 7. Because if we move minus 6 to left hand side to right hand side, we're going to have plus 6. So that's 7. That means alpha is going to equal to 3.5. Now, there's possibility that this question, or rather, not even that it's possible, this solution is not actually correct. This simultaneous equation is not actually correct. Because if we put in alpha is equal to 3.5 and beta is equal to 13 into this first equation, it's not going to be equal. But the reason why I still just said like that, I still just completely solved it, was because I'm the one who picked our vector A. Vector A was not given. That's why I said that question was a bonus. Vector A was not given. If I picked vector A very well, like if I'm the lecturer that said the question, I picked vector A very well, they are going to have a value of A and B that when you put it back inside equation 1, it will hold equality. If you put this inside equation 1, this here will be a whole number, while this will be a decimal point. By the time you subtract, you're going to have a fraction. and this our right hand side here is a whole number. So I know that this solution I just put now is actually wrong. But like you just let us assume our own, let us assume our own vector. Let's assume a vector minus 21 plus 25 minus 21 I plus 25j plus minus 4k. Now if you solve this simultaneous equation using this vector, you are going to have a alpha is equal to 1, beta is equal to 1, and it's going to also satisfy the first expression. Now the reason why you solve other simultaneous equation and you always get an answer for it, but in this case it's not all simultaneous equation you get an answer for, is because let me explain what this cross product is. You have a vector in this direction, you have another vector in this direction. The cross product is basically just a vector that's perpendicular to both of them. So already you have a vector in a particular direction, in a defined direction, and you have a vector in another direction. If I don't pick a vector that is perpendicular to these two vectors, I will not get a complete solution. That is why minus 21I plus 25j minus 4k works, because that vector is perpendicular to those two other vectors. But I plus j plus k would not work, because possible that I plus j plus k maybe in this direction is not directly perpendicular to these two direction. Let's say A and B. It's not directly perpendicular to A and B. The two of them at the same time must perpendicular to both of them. That is usually why the person that set the question must first of all solve the question, and after solving the question, he will now pick a vector that is in that direction that is perpendicular to those two vectors. I don't know if I'm making sense. Let's solve question 5 now. Question 5, we have find the angle between the vectors I minus 2j plus 3k and 3I minus 2j plus k. How do we find direction between two vectors? To find the direction between two vectors, you can use the dot product. Vector A dot vector B is equal to the magnitude of AB cos theta. We already know what vector A is, we know what vector B is. So let's find what A dot B is. A dot B is equal to I minus 2j plus 3k dot 3I minus 2j plus k. For dot product, we multiply the i's, multiply the j's, multiply the k, and sum them together. The question of i's here is 1 times 3, so you have 3, plus the question of j's here is minus 2 and minus 2, so you have plus 4. The question of k's here is 3 and 1, so you have plus 3. So this is equal to 3 plus 4 plus 3, which is equal to 10. So the dot product of vector A and vector B is 10. So that 10 must equal to the magnitude of A dot the magnitude of B cos theta. Okay? What's the magnitude of vector A? The magnitude of vector A is equal to the square root of 1 squared plus minus 2 squared plus 3 squared. Now the reason why it is 1 minus 2 and 3, because those are the coefficients of I, J, and K in the question here. And the coefficient of B is equal to the square root of 3 squared plus minus 2 squared plus 1 squared. 1 squared plus 4 plus 9 is equal to 14. So this here is equal to the square root of 14. 3 squared is 9 plus 4 plus 1 is equal to 19. So this here is also equal to the square root of 14. Therefore, the magnitude of vector A is equal to the square root of 14, and the magnitude of vector B is equal to the square root of 14. So we can proceed in our solution. So now you can simplify all this as 10 is equal to the square root of 14 times the square root of 14 cos theta. Square root of 14 times square root of 14 is equal to 14, because you have square root of 14 all squared, which is basically square and square root. So you have 14. So 10 is equal to 14 cos theta. So if you divide both sides by 14, you have 5 over 7 is equal to cos theta. Find the arc cos of both sides. You have theta is equal to cos inverse of 5 over 7. Calculator is not allowed, so there is no way for us to solve this. That is why the options are given us in terms of cos inverse and not decimal places. So you have cos inverse of 5 over 7, and that is option A. Question 6 now says, which of the following statements truly represents vector integral calculus? Which of the following truly represents vector integral calculus? Okay. Option A. The concept of vector integral calculus is the same as integral of real valued function, except that the result of a vector integral is a vector. That is completely true. Option B. The concept of vector integral calculus is different. No, it's not really different. It's the same. The exact same thing happens between both of them. The only difference is that if you integrate a normal scalar function, you are going to get a scalar. If you now integrate a vector, you are going to get a vector. So option B is wrong. Question C. Option C now says the result is a vector. Okay, they say it's not the same. Okay, option C is also wrong. D says it's the same, but if you integrate, the result will be a scalar. Option D is wrong. So for question 6, option A is the correct answer. Question 7. If F. Now question 7, now if you answer question 6 correctly, you'll be able to solve question 7. And in case you picked otherwise for option 6, for question 6, I wonder how you solve question 7, because question 7 it gave us a vector. Question 7 gave us a vector. So we're integrating a vector. So if you actually answer question 6 correctly, then you'll be able to solve question 7, because they basically does the same thing. They are basically just applying your answer for question 6. So question 6, the answer is option A. Let's now go to question 7. Question 7 says if vector F is equal to 3t cubed plus 2t, t cubed plus 3t, plus 3t I plus 2t squared j plus t minus 3k. We should calculate the integral from 0 to 1 of f with respect to t. Now if I integrate, as I said, it's basically the same thing as your normal integration. And your normal integration, if you have t cubed, it will turn to t to the power of 4 over 4. If you have 3t, it will turn to plus 3 over 2t squared. This is I. Plus, for j, you have 2 over 3 t cubed j plus t squared over 2 minus 3t k. Basically, it's the same way you integrate normally. But the only slight difference is that this is a definite integral. They told us from 0 to 1. So you are first of all going to impute the value of 1, then subtract it when it is 0. When it is 0, everything here will become 0. Because there's t here, there's t here, there's t here, there's t here, and there's t here. So you put in 0, all these terms will turn to 0i plus 0k plus 0j. Or rather 0i plus 0j plus 0k. And that is basically just a null vector, 0. So it does not have any effect. So I'm just going to impute 1, and that will be our answer. So this is equal to, when you put in 1, you have 1 over 4 plus 3 over 2. 1 over 4 plus 3 over 2 is same thing as 1 over 4 plus 7 over 4, which is 1 over 4 plus 3 over 2 is same thing as 1 over 4 plus 6 over 4, which is equal to 7 over 4. So this is 7 over 4i. 2 over 3 times 1 cube is same thing as 2 over 3. So this is plus 2 over 3j. T squared over 2 minus 3t when t is equal to 1 will be 1 over 2 minus 3, which is same thing as 1 over 2 minus 6 over 2 is same thing as minus 5 over 2. So we have minus 5 over 2k. And this is equal to option B. No, option A. 7 over 4i plus 2 over 3j minus 7 over not option A. Option D. 7 over 4i plus 2 over 3j minus 5 over 2k. That's option D. So this is how you solve it. You integrate normally as if you're integrating a normal function. Then you put in your definite integral back in. So it's just basically you're integrating. But what you get, the result you get is going to be a vector. I, j, and k is going to be a vector. Okay. Question 8. Since we have reached question 8, 9, and 10, I want to just explain something. That is grad, divergence, and coil. Okay, let me try and explain direction. No, not direction cosine. Let me try and explain gradient, coil, divergence, and coil. So the gradient of a scalar is basically just if you have a oh my god, come let me show my marker. Okay, the gradient of a scalar is basically just if you have a 3D, it mustn't be a 3D though, but it's reduced from 3D 3D, what do you call this thing? Let's say like 3D curves, yeah, 3D curves. So basically, in 2D, when you are drawing a 2D graph, what the result you get, the result that you get is basically just going to be a one-dimensional shape. I don't know if you understand what I'm saying. Like if you are drawing a 2D, the line that you are drawing is basically just is one-dimensional. It's moving up and down, but it's just a straight line, up, down, whatever. When you're finding the area of it below the graph, that's when you now get the area that is 2D. But the line itself is just one-dimensional. Now, when you're moving a step higher and you're using the 3D Cartesian plane with 3 points x, y, and z, the graph you're going to get is two-dimensional. It's two-dimensional. But when you're finding the area under, that's when you now get the area. That's when when you're finding the volume under, that's when you now get that sense of three-dimensional. You now get 3D. The same thing happens I just explained for 2D. The line you are drawing is one-dimensional. All lines you are drawing is one-dimensional. When you're finding the area under, that's when that sense, that idea of two-dimensional graph comes in play. I'm already sweating here. Okay. So now, this divergence, or rather, this gradient, the gradient of a scalar, basically, let us say you have a graph, a scheme like this. Okay. They normally draw them as a net, like this. Now, this thing basically it gives you the line vector that is what they call that thing again. That is basically the gradient. There's a name they call that thing. Tangent. It gives you the line vector that is tangent to that this skin. Now for two-dimensional, when you have a this thing, a curve like this, the tangent is also a straight line, right? The same thing happens here when you have three-dimensional, that is in 3D, and you have a two-dimensional shape. The tangent is also just one-dimensional. So that is what that gradient is. It's basically just a line. And how do you present lines in the course we're having now? Using vectors. So the gradient of a scalar is going to give you a vector. It's going to give you a straight line. That is the tangent of that that skin, that graph that you graphed in 3D, the 3D, that skin. That is basically what that gradient is. This skin here. That's what this gradient is. It's basically just the tangent at each point. Each point is going to be at maybe point z comma 0 comma 0 because x, y, and z is 0 here. Then this point here, the gradient here will now be the point for whatever a, b, and c is for x, y, and z. So that is basically what that thing is. So yeah, by the time you find, and how do you find the scalar basically? It's basically just the determine the derivative of the coefficient of I, the derivative of the coefficient of J, and the derivative of the coefficient of Z. So okay, I don't really know if we should go in depth because trying to explain from the basics is actually not my strong core. I am not here to teach you. I'm not your lecturer. I'm just here to solve the question. So I'm just going to solve the question like that. But I just want to give you a brief explanation of what this gradient is. So I don't really know how to explain for you in depthly. But in case you still want in-depth solution, please don't ask me in another video. I'll do that. But not in this video. Okay. Now let's move on to what the divergence explains. Now for divergence, as the name implies, does this function diverges or converges? Now, if you have, let us say, a sink here, and this your curve, right? It all just falls inside here. This your vector field. Let's say you have a magnet here. This your vector field, or let us say instead of magnet, let's use the earth. You have earth here, and all its gravitational force is pulling things downwards like this. In this case, the vector converges. In this case, you are going to have negative because they are all moving towards a particular point. This point. As at this point in space, this curve is basically just entering one point. Then for the divergence, when it diverges and is coming out, or when mass is created, or when the vector fields are created at the point, it diverges. So when you're testing, when you're finding the divergence or div of a function, let's how do you, okay, they call it a of a vector a. Remember when I was doing for gradient, instead of using any gradient, instead of saying grad f of x, I use the actual way they do it in maths using grad phi. So in this case, it's divergence of vector a, div a. It should tell you if that vector is diverging at that point or converging. So the divergence, if it's telling you if it's diverging or converging, it's not going to be a vector anymore, it's going to be a scalar. Because that scalar is going to tell you if it's positive, it diverges, if it's negative, it converges at a point. So now let's find what the coil of a vector is. And that divergence of A, div of A, is basically just nabla dot A. It's giving you a scalar. Grad phi is equal to nabla dot phi or nabla phi. For the coil of a vector A, the coil basically you have this vector here, and in this case we're going to use a magnet. So basically, you know the magnetic fields. I don't really know what I will use to represent, a field that goes around an object. But this is basically what the divergence, the coil of vector A tells you. Is that curve going around the point, or is it spinning the other direction? That's what this tells you. Now, how do you find the coil of vector A? The coil of vector A is equal to nabla cross A. So now with these 3 points, the divergence of vector A is equal to nabla dot A, and the grad or the gradient of a scalar field phi is equal to nabla phi. Okay, nabla is a scalar here. Sorry, nabla is a vector, nabla is a vector, nabla is a vector. Phi is a scalar, A is a vector, and A here is a vector. Okay, now let's solve question 8, 9, and 10. 8, 9, and 10. Question 8. If phi xyz, say the mass, we don't use grad f of x. You can try use it because phi is just a placeholder, but the standard is this. Just like the same way your quadratic equation, you can use minus b plus minus blah 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 blah. But you can also use minus x plus minus square root of y square, x, y, and z, a, b, and c. They are all just placeholders. They're just like variables. You can choose whatever letter you want to use as a variable. So you can also use f of x, y, and z, but the standard is using phi of x, y, and z. So you have phi of x, y, and z is equal to x cube yz plus xy square z cube. As I said, you have your 3D. Let's assume I've not plotted it before, but let's assume that the curve is something like this. Let's assume it's something like this. Okay. Now basically what they're asking us to find is what is the gradient of this function? What's the gradient of this function at the point 1, 2, 3? That is when x is 1, when y is 2, and when z is 3. What's the gradient at this point? What's the gradient at that point? Okay. Now how do you find grad phi? As I said before, grad phi is equal to nabla dot phi. Nabla dot phi. Nabla is equal to the derivative d dx of I plus d dy of j plus d dz of k. I'm multiplying this with phi. D dx of I plus d dy of j plus d dz of k times phi. Phi is equal to x cube yz plus xy square z cube. I don't really know how I'll do this with a small board, but where there's a will, there's a way. So I'm going to just turn the board flat. I believe I can solve more with the board flat like this. So we have, what was our phi again? Phi is equal to x cube yz plus xy square z cube. Okay. So remember how to do your multiplication. Okay. We have d dx of I plus d dy of j plus d dz of k times x cube yz plus xy square z cube. This would equal to d dx of x cube yz plus xy square z I plus d dy of x cube. You get the point, you get the gist. Basically just the same thing, multiply this, multiply that. So basically, yeah, first of all, we're going to find, oh god, I don't really know, this board is very small. Well, okay, first basically let me just do it one by one. I'm going to find the derivative of phi with respect to x, the partial derivative of phi with respect to x. You are going to find the partial derivative of phi with respect to y, and the partial derivative of phi with respect to z. The partial derivative of phi with respect to x is going to equal to, in this case now, we're only differentiating with respect to x. We're not going to care about y, z. Y and z will be constant. So that will be, if you differentiate x cubed, you are going to have 3x squared multiply y and z back. So that will be 3x squared yz plus differentiate x with respect to x, you are going to have 1. 1 times y squared z cube, that will be y squared z cube. Okay, I think this is a little bit better. So now let's find the derivative of phi with respect to y. Okay, this is equal to keeping x cube constant and z constant. Differentiate y, you are going to have 1 plus keep x z cube constant. Differentiate y square, you are going to have 2y. So the derivative of phi with respect to x is 3x square yz plus y square z cube. The derivative of phi with respect to y is equal to x cube z plus 2xy z cube. The derivative of phi with respect to z, the same thing happens. Keep x cube y constant, differentiate z, you are going to have x cube y plus keep xy square constant, differentiate z cube, you are going to have 3z squared. So we have basically differentiated the three of them with respect to x, with respect to y, and with respect to z. Okay. Remember, this here will have I at the ending. Then this will have J. This will have K. If we are solving in theory, please remember to put this in a straight line, on just in a straight line. And when you are solving, it will be just this times I plus this times J plus this. You don't need to do them separately. I'm only doing them separately because there's no space on my board. When you are solving, please just put them together on a straight line. But since it's theory, you can try to do them separately and nobody will care. But if it's if it's OBJ, you can do them separately and nobody will care. But if it's theory and they will need to see your solution, you actually need to put on straight line. There's no need for you to do them separately. But if you put them separately, it will not actually affect your mark. But you still just do it on straight line. If there's space on your paper, just do it on straight line. Okay. So now we need to see we have differentiated each of them. I have got each term. This is our the equation for I, the equation for J, and the equation for K. So now let's put our this thing, the point that we're finding out. We're finding it at xyz is equal to 1, 2, 3. That is when x is equal to 1, when y is equal to 2, and when z is equal to 3. When x equals to 1 and y equals to 2 and z equals to 3, the derivative of phi with respect to x would equal to 3 times 1 times 2 times 3, and that is 18, plus y squared is 4 times z cube is 9, 27, sorry. 4 times 27 is 54, 108. 108 I plus the derivative of this with respect to y. If we are putting in x equals to 1, y equals to 2, and z equals to 3, we are going to have z, that is 3, plus 2 times 1 times 2, that is 4. 4 times 3 cube, that is still 108. J plus x cube y. X cube is basically just 1, so that's y, that's 2 plus 3 times 1 times 4 times 9, that's 4 times 27, which is 108. Then K. I've been trying my best to be doing this recording in the office so that I can have a bigger board that I can solve as much as I want without having to clean every single time. But sometimes it's better to just record this at hostel when I know I'm going to be busy doing class. Okay. Okay. 18 plus 108 will be 126 I plus 3 plus this, that is 111 J plus 110 K. Was there no minus? I can remember having a minus. But anyways, this is what I'm solving now. So when you're solving your own, please cross check. Make sure that okay, there's supposed to actually be a minus. But yeah. 3 no. I know I solved this thing well. So there's no minus sharp, but all the options here, none of them are correct. A here is 126 I minus 111 J plus 110 K. B also has minus, C has minus, and D has minus in it. So I'm going to go with E, none of the above. Though I can actually remember solving this in class and getting a minus. Okay. So question 8 is E, none of the above. But you can see what the correct answer is supposed to be. All of them are supposed to be plus, they're not supposed to be minus. Question 9. Okay. Okay. Question 9 gives us a vector A is equal. Remember, as I said, all these things are just placeholders. Phi, A, whatever, they're all just placeholders. They are variables. You can pick your own variable. Just that in maths, they are standards. There are some things that it's not like everybody must use them, but whenever you see them, you already know where they are attached to. If I come to you and I just walk up to you and I tell you minus b plus minus square root of b square minus 4, you would already, if I even complete, you say that's quadratic formula. So they're just standards to all these things. There are some ways to put them. If I come to you and I tell you minus x plus minus square root of y square minus 4, you can say I'm even saying this slowly. I'm not saying as fast as I did for the first one, because I'm not be saying that's not been saying. Oh, but if I say that it's still going to be correct. It's still the quadratic equation. But the way that quadratic equation will not be for maybe x I no x maybe x, let me not use I because we are usually doing vector now, so you not confuse each of them. But let's say I tell you x, let's use j k z x whole squared, yes, x whole squared plus, oh my, confused with 0, x b c d e f. Okay, let's say x f squared plus y f plus z. The quadratic equation for the quadratic formula for this one is going to be minus x plus minus, sorry, minus y plus minus the square root of y squared minus 4xz divided by 2x. It's still correct. This is the quadratic formula for this particular quadratic expression. But I said there are standards to it. The standard way to write quadratic formula is going to be ax squared plus bx plus c. That does not basically mean that this is wrong. It is me that picked these variables for myself. So in case you see inside the example, and instead of phi x y z, they now say f of x y z. Don't say that the question is wrong and you pick none of the above. F here was going to be used in place of phi. Phi is just the standard way of writing it in maths, but f can also be used. In case they can also use g of x, they can use h of x, they can use any letter they want. Instead of x, y, and z, they can even use a, b, and c. So I'm just telling you that these are just placeholders. Now in this question, so they use the standard letter. The standard letter is capital letter A for vector A. That is when you are finding the coil and divergence. It is the div A and coil A. But I'm just saying that in case you say that the example and tell you vector C, capital C, and you're not going to say, no, since it's not vector A they gave you and they give vector C, then the question is wrong. Then it is you that is doing yourself. Okay, I'm just going to just clear that out. Let's solve this question. This question gives us I know some people will be like, there's no point pointing that out, that who will make that kind of mistake and say that the question is wrong just because they gave them a different letter. I'm telling that some people that I don't want to say use the word cramming because some people may find it hard, but there's some people that just cram examples, enter inside the example. So whenever they see something different from the example that they've crammed, they totally, just lost it and they'll say, oh, this is not part of the thing that I learned in the past notes. So this question must be wrong. I'm just telling you that you can see something like this. Okay. In this case, I use the. In fact, okay, no, that's not part of it. I wanted to just say question 7, they gave us f instead of I. It doesn't matter, question 7 asked us to integrate. It was not part of the divergence, coil, and gradient questions. So question 9 now says, if A is equal to x squared y I minus xyz j plus 2yz k, where I, j, and k are our unit vectors in the x, y, z coordinates. We should find the divergence of A at point 1, 2, 3. That's basically when x equals 1, y equals 2, and z equals 3. For space, I'm going to just clean this off. Remember that your divergence of A is equal to nabla dot A. And nabla dot A is equal to the derivative of the coefficient of I, that is the derivative of ax with respect to x, plus the derivative of ay with respect to y, plus the derivative of az with respect to z. I don't really know if I should explain why this is the simplified version, but I am just going to explain that. Nabla on its own is equal to the derivative d dxi plus, actually supposed to be the partial derivative d dxi plus d dyj plus partial d dz k. I am multiplying this with a vector A, which we are going to just assume is axi plus ayj plus azk. Remember, when you are finding your dot product, you multiply the coefficient of I plus you multiply the coefficient of j plus you multiply the coefficient of k. So that's what we are going to do now. Multiply the coefficient of i's. We are going to have the partial ax, partial x. No, not I again. because I times I dot I is basically just 1. So they're not going to put I again here. So that's partial AX plus partial AY with respect to Y plus partial AZ with respect to Z. So that's basically how they got that simplified version. Instead of just putting abla dot A, you can just get this. So you're going to differentiate the equation of I with respect to X plus the differentiate the equation of J with respect to Y plus differentiate the equation of K here with respect to Z. The divergence of A is equal to, okay, I simplify this to partial AX partial X plus partial AY partial Y plus partial AZ partial Z. So this is our equation of I, which is our AX, which is x square y. AX is equal to x square y. So the partial AX over partial x is going to equal to 2x y. Remember, you are keeping every other thing constant besides x. And x here is x squared. Differentiate x squared, you are going to have 2x times y, because y was the constant here. Okay? You have ay is going to equal to minus xyz. Minus xyz. So you have the partial ay over partial y. Minus xz is going to be our constant here. We are differentiating y with respect to y. That will be 1. So this is just going to equal to minus xz. Our az in this case is equal to 2yz. Our partial az with respect to x, with respect to z, is going to equal to 2y. Because like I said, 2y is going to be our constant here, and z is our what we are differentiating with. So you have partial z over partial z, that is equal to 1. So you just have 2y times 1, which is just 2y. So this is this plus this, and that is 2xy minus xz plus 2y. Now put in that point. They say that point x equals to 1, y equals to 2, and z equals to 3. When x equals to 1 and y equals to 2, you are going to have 2 times 1 times 2, that is 4. When x equals to 1 and z equals to 3, you are going to have minus 3 here. When y equals to 2, 2 times 2, that is 4. So you have 4 minus 3, that is 1, plus 4, that is 5. 1 plus 4, that is 5. So our divergence of A at this point is going to equal to C. That is C. That is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is C. It's going to equal to 5. And that's option C. Let's move on to the next question, question 10. Question 10 says we should find the coil of vector A at the same point as the previous one. If vector A, whoa, okay, this is going to be much longer. So I don't really know how I'll do this, that it will be simpler. You know what, I'm going to do the same thing I did for the first one. I'm going to solve them individually, then add them. So in this case, you have vector A. To avoid this video from getting too long, I'm going to just, question 10, I will solve it separately in another totally different video, because this question, this one is actually very long. This board will not satisfy. I will take my laptop to LT tomorrow and record, because my tablet cannot record again. So I'll take my laptop to LT tomorrow and record the video for the solution for question 10. And I'll set that one aside. I'll create that as a different video entirely. So I'll solve it, because this one actually you're going to use matrix. No, I don't like that matrix method for solving cross product. But in case you prefer matrix method, you can use matrix method. You might prefer using this in the normal way. If I have AXI plus AYJ plus AZK. In fact, why am I doing this? I actually did it before. I did cross product before. I did cross product when I was solving question 4. I did cross product when I was solving question 4. The way I solved question 4 using that cross product without needing the matrix method, that is why I prefer solving for cross products. I don't like doing the matrix method. But you can, if you like the matrix method, you can also do that if you like it. But anyways, now that I'm going to solve this as an entirely different videos on its own. Just like the way I did last year when I was doing Maths 111 test review. For test 2, I did Question 15 entirely different. So that's why I'm going to question 10. This one entirely different. So let's go to question 11. Question 11 is actually no more in the vector aspect. Question 11 now it is coordinate geometry. Question 11 now says which of the following statements is truly correct? Line rises from right to left. They don't tell us which line rises from right to left, so let's keep that aside. Line falls from right to left. Let's keep that aside also. Horizontal line is positive slope. No, a horizontal line has a slope of 0. A horizontal line has a slope. The y dx would be equal to 0. So no, the horizontal line does not have a slope of 0. A vertical line is negative slope. You have a vertical line like this. The derivative, the y dx, would equal to be undefined, or some people can call it infinity. So no, a vertical slope is not negatively sloped. So instead, I'm going to go option E, none of the above. Now, if they say something like a line that rises from right to left, that is the answer for this question is none of the above. But just in case this is a question in exam and they maybe they change the option, and instead they said the line that rises from right to left, it rises from right to left. This will be a negative slope. This will be a negative slope. Because another way of saying rises from right to left is also saying it's falling from left to right. And that is how you define a negative slope. It's falling from left to right. Another way for defining a negative slope is basically if y here is positive and x here, that is where the cos x and y is both positive, or when they are both negative. When they are both negative, when it falls and they fall and they are both negative, then it will give you a negative slope. But if you have a positive slope, it will rise from left to right. And this will give a positive slope. Another way to define a positive slope is if one of them is positive and the other one is negative. In this case, the x-axis is positive and the y-axis is negative. Another way you can get the positive slope is if it rises like this. In this case, the x-axis is negative and the y-axis is positive. So these are the ways of doing positive slope. Why negative slope are like this. So if the question came out as a positive slope rises from right to left, sorry, a negative slope rises from right to left, then you would have gone, that would be correct. Or they tell you a positive slope rises from left to right, it would be correct. Or falls from right to left, because it falls from right to left, then that would have been correct. But in this case, just say that line rises from right to left. That is wrong. Not all line rises from right to left. The B now says line falls from right to left. Wrong. Not all line falls from right to left. C says horizontal line is positive slope. I explained that already. Wrong. And D, wrong. So option E, none of the above, is correct. Question 12. Find the equation of the line passing through points P and Q. So you have the line passing through points. I did not draw the graph. We need negative. Okay. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is -1, -2. Okay, this is 1. So it passes through the point P, which is -2, 1, -2, 1. This is point P. And point Q, which is 1, 9. Point Q. So basically, I'm looking for the line that passes through these 2 points. The straight line that passes through these 2 points. Now, how do we do this? We already know the equation for the straight line. The general form of an equation for a straight line is y is equal to mx plus c, where m is our gradient. So if you have y minus c is equal to mx, you can basically just get y minus y1 is equal to the gradient times x minus x1. What else can you get from here? You can get that y minus y1 is equal to, our gradient is equal to what? Y1 minus y2 divided by x1 minus x2 times x1 minus x1. Sorry, x minus x1. So these are basically ways of writing it. You can get this one as a general form of a line. You can get this if you are given the gradient. If you are given the gradient and you are given a point, a gradient and a point. You can now use this if you are given 2 points. So you use this for to get your 2 points, and you use this as you use just pick any random point and use there. Okay, any random point that you are given, that is, you will be given 2 points. You use the two of the point to get your gradient. Then you can pick any of the two that you are given to use to get as your second point. So for this question, we're going to use them as we are given. Our point one is going to be -2 and 0, and our point two would be 1,9. So if our point one p is equal to -2 and 0, that means x1 is equal to -2 and y1 is equal to 0. That also means that x2 is equal to 1 and y2 is equal to 9. Okay, I believe I can clean this. I believe you have gotten that down, written down already. Okay, so we can use that our formula y minus y1, y minus 0 is equal to y2 9 minus y1 0 divided by x2 1 minus 2 times x minus x1 minus 2. Okay, y minus 0 is just going to be y is equal to 9 minus 0, that is just 9. 1 minus 2 is 3, and x minus 2 is x plus 2. So you have 9 divided by 3, that is just 3. So you have y is equal to 3x plus 6. Y is equal to 3x plus 6, and that is option C. Okay, let's go to the next question. The next question asks, next question 12, find the equation of the line that passes through 2 points. No, I've saw that already. Question 13, if A is a point 2, minus 3 and B is the point -1, 9, find the gradient of the line perpendicular to A and B. So now we have 2 points A. We need -3, -1, -2, -3. We need -1. We need 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we need 2. 1, 2. So we have 2, -3. That is this point here. This is our point A. And our point B is -1, 9. That is this point here. This is our B. So basically, we have this line AB. But that's not the question they asked us to find though. They said we should find the line, the gradient of line that's perpendicular to A and B. So this is a line that's perpendicular to A and B here. So the first thing we're going to find is the gradient of A and B. We call that M1. Then we now find M2. We find M2 by doing what? M2 is equal to -1 divided by M1. I don't really want to waste too much time proving this. But if you want to prove this, you can prove this by finding, let's say you have a line here and another line here. I want to find the angle between them. The angle between them is alpha. The angle here is theta. You know that tan alpha plus theta is equal to tan alpha plus tan theta, or rather, let's call this angle here, the whole angle down here, alpha. So we have that tan theta, or rather alpha minus theta. You have tan alpha minus theta is equal to tan alpha minus tan theta divided by 1 plus tan alpha tan theta. Tan alpha is the gradient of the first line M1, and this is M2. That is M1 here, and here is M2. You have M1, M2 down here. Okay. Then this one is the gradient, basically just the angle between them. Angle between them. The tangent of the angle between them. So now, if the angle between them is 0, then they are parallel. The tan of 0 is 0. That means M1 minus M2 is equal to 0. That means M1 is equal to M2. So if they are parallel, M1 is equal to M2. And if the angle between them is 90, that is perpendicular, tangent of 90 is 1. So that means, wait, tan 90 is not 1. Tan 90 is undefined, 1 divided by 0. That means 1 plus M1 M2 must equal to 0. That means M1 M2 must equal to -1. That means m1 is equal to minus 1 over m2. That's basically how I just prove it. I said I'm not going to prove it, but then I just did it. But that's basically how you prove it. You have m2 is equal to minus 1 over m1. So that's how you get that formula, that expression, m2 is equal to minus 1 over m1 if they are perpendicular. So now let's solve this. First, the first thing we need to do is to find our gradient, m1. To get m1, m1 is equal to the gradient of those 2 points. That is 9 minus bracket minus 3 divided by minus 1 minus 2. 9 minus 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 3 minus 1 minus 2. This is equal to 9 plus 3 divided by minus 3, which is equal to minus 4. But this is not the end of the question. They say we should find the one that is perpendicular. The one that is perpendicular is going to be minus 1 divided by minus 4. Remember, m2 is equal to minus 1 over m1. Our m1 is equal to minus 4. In fact, there's no option for minus 4 here. So once you reach that point, you open that total issue that you need to go a step further. So you have minus 1 over minus 4, which is equal to 1 over 4. And this is option B. Option B, 1 over 4. Question 14. Question 14. Write an equation of the line parallel to the graph 3x plus y is equal to 6 that passes through the point blah blah blah. So let us say we have 3x plus y is equal to 6. Let us say that graph is going to be a negative graph. So let's say like this. They say that this line should be parallel. So this our second line should parallel to it and should also pass the point 1, 4. Should pass this point 1, 4. So now the first thing you need to find is number 1, if you have y1 equals to m bracket x minus x1, what you already have the points that you are given. This point here is 1, 4. But we need to find our gradient. Remember, this gradient here will equal to the same gradient as this other line here. So if you can get the gradient of this line here, then we know our gradient for this our new line that so what am I stammering? If you can find your gradient of this line here that we are given, then you will be able to find the gradient of the line that we were asked to find. Okay? And if you get the gradient of the line that we are asked to find, you already have the gradient and the point, so you cannot get the equation of the line. So now, the first task that we are given is to find the gradient of that line that we were given. The line that we are given was 3x plus y is equal to 6. Remember that y is equal to mx plus c, where m is our gradient. So now let's make y simple. So here y is equal to minus 3x plus 6. So our gradient m1 is equal to minus 3. But remember, since they are parallel, m1 is equal to m2. So m2 is also going to equal to minus 3. Let's put all that inside our formula. You have y minus y1 is equal to minus 3 bracket open x minus x1. y1 is equal to 1. No, y1 is equal to 4 and x1 is equal to 1. So you have y minus 4 is equal to minus 3 bracket x minus 1. So this is equal to y. So this is equal to y minus 4 is equal to minus 3x plus 3. Y minus 3x, sorry, y is equal to minus 3x plus 7. So you have y is equal to minus 3x plus 7, and this is option D. Question 15. Question 15. Write an equation of the line perpendicular to the graph of, okay, we have a line, a graph like this. It's a positive graph, so you're going to have something like this. You have a graph like that, and they say we should find the equation of the line that's perpendicular, as it should be perpendicular to this line that passes through a point. It passes through the point minus 3, 8. So that's basically the setup. And the same thing goes, we already have that point, so we need to find the gradient. But in this case, m2 is not equal to m1. In this case, m2 is equal to minus 1 over m1 because they said perpendicular. So let's find our m1. The line that we are given is y is equal to 1 over 4x plus 5. It's already easy to find your m1. m1 is equal to 1 over 4. So our m2 is equal to minus 1 divided by 1 over 4, which is equal to minus 4. That's our m2. So now let's put that back into our expression. You have y minus y1. Our y1 in this case is 8 is equal to, hey, what else? Okay, minus 4, yeah. Minus 4 bracket open x minus minus 3. This will be y minus 8 is equal to minus 4 bracket open x plus 3. y minus 8 is equal to minus 4x minus 12. You have y is equal to minus 4x minus 4. The options here were minus 4x plus 4, minus 3x plus 7, minus x plus 1 over 4, and y is equal to x plus 4. None of them matches y is equal to minus 4x minus 4. Remember, it's minus 4 here, not plus 4. The option here, option B, says plus 4, which is wrong. So this answer here is E, none of the above. This brings us to the end of this Maths 1, 2, 3, 2025 and 2026 test 2, test 1 review. Thank you for watching. I'm going to create the solution to question 10 later on tomorrow. Then I would post it on its own as a separate video. I hope
Calculate. Check the variables, running up commas, that's summation. Solve for x, that's a new placement. The logic solid, every play is prime. Stacking these numbers, yes, my design. All my moves connect like ordered pairs. Got the whole game mapped out on my graphs.